Hello everybody, good morning. I hope you're doing very well. Today we're going to go over how to solve exponential equations, and we're going to do that by finding some common bases. But before we do that, how about we explore what an exponential equation is? So an exponential equation is an equation in which a variable is in the exponent. We've dealt with equations where the variable is in the base, but we've never dealt with an equation that has a variable in an exponent before. And some examples we have is 2 to the power of x is equal to 2, or 4 to the power of x plus 1 equals 16. These are exponential equations. First off, equations have to have equal signs, and it's because the variables are in the exponents. So how do we solve 2 to the x equals 2? Well, this one is about as straightforward as we can get. 2 to what power gives us 2? And we know that 2 to the first power will give us 2. But what's another way we can think of this is that 2 to the x is equal to 2 to the first power. And then you'll notice, right, because we got 2 to the first power equals 2, that x is going to be equal to 1. So just think a little bit about what's happening. We're going to hopefully develop a pattern here where we can see how we solve for the variable. If in this example we have 2 to the power of x equals 2 to the power of 3, well, how can we figure out what x is? And clearly, there's not really any work that we can do here, is that 2 to the x equals 2 to the third power, that the x would have to be equal to 3 in this particular example. So if the bases are the same, then the exponents are going to be equal to each other. So if b to the power of x is equal to b to the power of y, then we know that x is equal to y. So if we look at this first example of 2 to the power of x minus 3 is equal to 2 to the power of x plus 5, we can see right away that our bases are equal to each other. This has a base of 2. This has a base of 2. So since the bases are equal to each other, we can set the exponents equal to each other and solve. So we're going to have x minus 3 is equal to 2x plus 5, and we can solve for x. First, we subtract x from each side. That gets us negative 3 is equal to x plus 5. Then we are just going to subtract 5 from each side. And we get x is equal to negative 8. Let me scroll down so you can see. And there we go. What if the bases are not the same, though? What if we have 2 to the x is equal to 4? Well, we know at this stage of our lives that 2 squared is going to be equal to 4, that x is equal to 2, because that would mean that 2 to the x is equal to, well, 4 is just 2 squared, right? Because we know that at this point. So notice what we did, though, is I rewrote 4 as 2 squared. Now, why did I do that? Is, oh, look, we have common bases now. So then we could just do what we've been doing, which is, oh, well, now the bases are the same. So we drop the bases and just set our exponents equal to each other, and we get x is equal to 2. For 2 to the x is equal to 16, hopefully at this point you know that x would be equal to 4, because 2 times 2 is 4, times 2 is 8, times 2 is 16. So we can see that x is going to be equal to 4. However, that means that 2 to the power of x is equal to, well, 16 is 2 to the fourth power. And oh, look at that. We've turned it into a problem where we have common bases. We can rewrite the number 16 as 2 to the fourth power. Now we have common bases. So when we have common bases that are equal to each other, we drop the bases and set the exponents equal to each other. And we just get, as a final answer, x is equal to 4. Here we have 3 to the power of 2x is equal to 27. Now, the other ones were easy because we just had 2 to the power of x equals 4, 2 to the power of x is 16, so it kind of makes sense. right? But here we have 3 to the power of 2x is equal to 27. This one is not as straightforward. But can you think of a way we can rewrite the number 27 using a base of 3? Normally I ask the class here, but I don't have that luxury. So hopefully you're saying, well, yes, that means 3 to the 2x is equal to, well, 3 to what power is 27? And that's 3 to the third power, because 3 times 3 is 9, times 3 is 27. So we rewrote the number 27 using a base of 3. And now we have a new equation, right? It's the same equation, just written differently. But now we have common bases, so we can now drop our bases and just rewrite this as our exponents equal to each other. 2x is equal to 3, and then just solve for x. How do we do that? We divide by 2 each side, and we get x is equal to 3 halves. X is equal to 3 halves. All right, so all we did was we found a common base. We said, all right, I can put these in a common base, and then we can use our rule where we set our exponents equal to each other. I have no idea why the camera is shaking like that. I'm sorry. So here's an example. We have 7 to the 2x plus 1 is equal to 7 to the 3x minus 2. We have our common bases already. So when the bases are the same, we can drop the bases and set our exponents equal to each other. So we get 2x plus 1 equals 3x minus 2. And then we just solve for x. So we subtract 2x from each side. We get 1 equals x minus 2. Right? Those cancel out. 3x minus 2x is 1. And then we just add 2 to each side. And we get x is equal to 3. We get x is equal to 3. When it's common bases, just drop the bases, set the exponents equal to each other, and solve. Okay, what if we have a problem set up like this? 3 to the 2x minus 1 equals 27 to the power of x. So here we can't just drop the exponents and set them equal to each other because we don't have common bases. We do have exponents on each side, though, which we haven't seen yet. But just focus on the bases for a minute and just ignore the exponents. We have a base of 3 and a base of 27. How can we write them so they're in a common base? What is the common base between 3 and 27? And hopefully you're saying, oh, well, that's 3. And I'll say, good. So we keep this 3 to the power of 2x minus 1. Now, 3 to what power is 27? That's 3 cubed. So that 27, we're just rewriting as 3 cubed. But that 27 is being raised to an exponent. So this becomes 3 to the third power, which is our 27, and that's being raised to the power of x. This is where our rules of exponents are crucial to understand, because when you have a power raised to a power, we keep the base as 3, and what do we do to those exponents is we multiply them. So 27 to the power of x is going to simplify all the way to 3 to the power of 3x, because we have 3 to the third power to the power of x. So we keep that 3 and we multiply our exponent of 3x. On our left side, it's just going to stay 3 to the 2x minus 1. Now we've set up the problem where we can solve it because we have common bases that are 3. So we drop the bases and just set 2x minus 1 equal to 3x. We do 2x minus 1 equal to 3x. Just gonna give myself a little bit of room. Actually, let me pause this. I'll rewrite it. So we had our 2x minus 1 is equal to 3x. We subtract 2x from each side. And we get negative 1 is equal to x. Okay, so that's how we solve this problem. We started out with, there it is, 3 to the 2x minus 1 is equal to 27x. We were able to find common bases and solve it to be x is equal to negative 1. 5 to the 3x minus 8 equals 25 to the power of 2x. ignore the exponents for a minute. Just look at 5 and 25 and say, okay, is there a common base between 5 and 25? And hopefully you're saying yes, because I can rewrite 25 as 5 squared. So 25 is 5 squared, and that's still being raised to the power of 2x. So 25 to the 2x becomes 5 squared to the 2x, because 5 squared is 25. Left side stays 5 to the 3x minus 8. When you have a power raised to a power, you have to multiply them. So this is going to stay 5 to the 3x minus 8. This is going to become 5 to the 2 times 2x is 4x. So we can, 25 to the 2x becomes 5 to the power of 4x. Those are equal to the same thing. Drop the bases, set the exponents equal to each other. 3x minus 8 equals 4x. Subtract 3x from each side, and we get that negative 8 is equal to x. There's our final answer. Here we go. What about this one? 1 over 4 equals 8 to the power of x. Now, I don't know about you, but I can't figure out a common base when it's written as 1/4. So how can we rewrite 1/4 where we do not have a fractional base? You're raising your virtual hand, I'm calling on you, and you're saying, oh, this is just 4 to the power of negative 1 is going to be equal to 8 to the x. Yeah, we can rewrite that number 1/4 to just be 4 to the power of negative 1. Now, we just look and we say, all right, we have a base of 4 and a base of 8. What is a common base between them? And don't say 4, because 4 squared is equal to 16. So it's not 4. You got to think lower than 4 and say, okay, I can make this 4 2 squared, and that'll be raised to the negative first power, because 4 is 2 squared being raised to the negative first power. And this 8, well, that's 2 cubed, and that's being raised to the x. So 8 became 2 cubed. That's still being raised to the power of x. When you have a power raised to a power, you multiply the exponents. So this becomes 2 to the negative 2 power is equal to 2 to the 3x power. So we started with 1 over 4 equals 8 to the x, and we used our rules of exponents and found common bases, and we rewrote it now to something that is solvable as 2 to the negative 2 equals 2 to the power of 3x. At this point, we can drop our bases, set our exponents equal to each other. So we have, let's write this up here, negative 2 is equal to 3x. We divide both sides by 3, and we get x is equal to negative 2/3. So just because it looks this way doesn't mean it's not solvable, and it doesn't mean it's impossible. You just take it step by step. What if we have a problem like this? 2 to the negative 2x times 2 to the x plus 1 equals 2 to the negative 2x. Well, here we've got all bases of 2, so we can just drop the bases and set the exponents equal to each other, right? No, we can't do that until we have one term on the left side and one term on the right side. One term equals one term. Then we can drop the bases. So we've got to figure out what happens on the left side of this equation when we've got 2 to the negative 2x times 2 to the power of x plus 1. Do you remember your rules of exponents? When we have common bases being multiplied, what do? We keep the bases 2, and we add the exponents, negative 2x plus x plus 1. That equals 2 to the negative 2x. Right? We keep the base, we add the exponents. So now we have negative 2x plus x, which is just going to be negative x. So 2 to the negative x plus 1 equals 2 to the negative 2x. Now we have one term equals one term. At this point, you can drop the bases and set the exponents equal to each other. Negative x plus 1 equals negative 2x. We add 2x to each side, plus 2x plus 2x. We subtract 1 from each side, Negative x plus 2x is x, and equals -1. And that is our final answer. Okay, last one I'm going to bother you with. 1 over 8 to the power of 3x times 64 to the power of 2x plus 1 equals 4. Right? If I wrote this on the board, it would have a star next to it. And I'd give you probably extra credit to try and do this. But here we go. What did I tell you we can do when we have a fraction as our base? Is we don't want that as a fraction. So we're going to rewrite this as 8 to the power of -1. That's being raised to the 3x times 64 to the 2x plus 1 equals 4. And you have a power raised to a power, so we multiply it. So we get 8 to the power of -3x times 64 to the power of 2x plus 1 equals 4. So we've got 3 different bases here, 8, 64, and 4. And is there some common base that they all have? Something that they can all be written in a common power of? And I hope you're screaming at your YouTube that yes, the answer is 2. So we can rewrite this 8 as 2 to the 3rd power. And that's being raised to -3x. Hold on, guys. Sorry, had daddy duty to take care of. So we've got 8 is 2 to the 3rd power, so that'll be 2 to the 3rd, and that's being raised to -3x. 64 is 2 to the 6th power, and that's being raised to the power of 2x plus 1 equals, well, 4 is 2 squared. So we've got 2 cubed to the -3x times 2 to the 6th to the 2x plus 1 equals 2 squared. I know it looks crazy, but if you think about it, we didn't do anything that's too crazy. Hold on, guys. So we have 2 cubed to the -3x times 2 to the 6th to the power of 2x plus 1 equals 2. Power raised to a power means we multiply. So this is 2 to the 3 times -3x is -9x times. Now, you got to be careful here because we're multiplying 6 times 2x plus 1. So what you have to remember to do with this is distribute. You've got to distribute that 6. 6 times 2x is 12x plus 1 is going to be 6. So this is going to become 2 to the 12x plus 6. You have to remember to distribute. And this is equal to 2 squared. All right, and then now when you've got common bases being multiplied, we add the exponents. So this is 2 to the power of -9x plus 12x plus 6 equals 2 squared. -9 plus 12, 2 to the 3x plus 6 equals 2 squared. And then now we can drop the bases and set 3x plus 6 equal to 2. So we're just going to have 3x plus 6 equal to 2. And now we just solve. We subtract 6. 3x equals -4. We divide by 3. And we get x is equal to -4 over 3. So there you have it. I know it looks crazy, but again, just take it slow, take it step by step. It really is not very difficult. Try and break it down to piece by piece. Don't try and do everything at once. You will overwhelm yourself and completely not understand what is happening. So it's Friday, we're done. Just get your work done quickly today, because it's Friday, so this way you have nothing to do over the weekend. I'm not going to give you any work over the weekend. Just try and do your work today. Keep to a schedule. It will help you stay on top of all your schoolwork. I know this is new for you guys. This is brand new for me. I'm still learning how to properly teach this way. So I will always welcome any suggestions you guys have that I can do. As always, email me if you have any questions and you don't understand something. I will try to explain it to you personally or a different way. And have a great weekend, everyone. Stay safe, wash your hands, and have a good quarantine. Peace!